gone before the last 2 days is a preliminary to writing a redirector or a, not necessarily to a server, but in some aspects to a server. This morning we've had, as I think I mentioned on Tuesday, we've got a slight schedule change. You're going to get to listen to my dulcet tones for the first hour and a half, and I'm going to talk about advanced TDI and servers. And TDI, if you don't know what TDI is, hopefully if you're here and you're really thinking about writing a server or a redirector, you do. But TDI stands for Transport Driver Interface, which is our interface that we developed with Windows NT to give us a fast path within the kernel to transports. And it uses some unique aspects of NT to do that. First, though, I was a bit disturbed last night by some of the questions I heard, especially around David Goebel's talk, and specifically about the levels of complexity that David exposed. And so I was inspired last night to go home and write what I call a little bit of a pep talk for people who are really interested in doing file systems. And if no one has a major objection to that, I'm going to go ahead and run through those 5 slides right now and talk a little bit about what I see as the path to implementing a file system starting from scratch and the order that I would implement the pieces of functionality in. Anybody have any objections to that? Okay, I don't have copies of these slides. We're winging it from here. This is live. So yeah, IFS the movie will have it. And I will copy the slides and send them to everyone afterwards. And actually, it occurred to me this morning on my way across the bridge that perhaps the right thing for me to do would actually be to write some sort of a white paper that's an overview guide to implementing a file system. And maybe the right person to write that is really Mary and not me, but Yes, I actually called it PEP. So I had to have some kind of a name. Okay. What David talked about yesterday, and to a certain extent what Tom and Lou talked about, is commonly referred to in the Windows NT group as folklore. It's not written down anywhere. If you don't wander the northwest hallway of the bottom floor of Building 2, which is where all the file system people and Daryl are located, it's very difficult to get this information. Even people who do wander those hallways sometimes have trouble getting that information. So what we wanted to do as a part of this conference, and part of the reason for giving it a videotapes, is I wanted to make sure that we got that folklore information as much as possible onto videotapes and into some form that you could use it. That's why a couple of people have come up to me and asked me, Gene, are we really getting videotapes? Yes, we're really going to send you all the videotapes of this conference, because for the near future, until we do another rev of the documentation, a lot of the documentation is in fact those videotapes. So we wanted to make certain in these 2 days that we gave you all of the information you would need, or 98% of the information you would need to implement a file system. In doing that, we may have given you a little too much information to make it difficult for you to actually figure out where to get started. The message I want to present here is, I really want you to lose complexity in your file system. If the kind of file system you envision ultimately building is in fact something that's highly cached and incredibly fast and extremely functional and does everything you might possibly ever want it to do, don't start implementing that file system. Implement a very simple file system to start with and go from there. What I would suggest you do if you're going to implement a file system, gut CDFS. We've given you the code for CDFS. You know that file system works. You know it supports most of the entry points, if not all of the entry points, with the exception of write, that a file system needs to support. So retain the dispatch routine for CDFS, retain some of the initialization code that creates the device objects, etc., and just dump the rest. Start pumping your stuff into it. If you go ahead and build a non-cached, procedure-based version of your file system, I mean, procedure-based if you must. For some of you who come from Unix, that's a more familiar way to program. But if you spin off your own thread in the kernel and you implement your file system in the context of that thread, which is a very doable thing, then it's much easier to implement sometimes and much easier to understand for you. Ignore caching. Ignore fast I/O. If you ignore these things, everything that David Goebel talked about in his talk yesterday can be ignored. So 2.5 hours of the world's fastest talker can be ignored for the immediate, the near term, immediately. Ignore paging files, ignore paging I/O. If you do that, a lot of the stuff that Lou talked about can be ignored in the near term. Okay, so now I've just made the, at least for getting started, I've just made the file system conference pretty useless. So we'll go on from that. Take your file system and use regedit 32, which is in the SDK, and plug the registry values in that allow you to manually load your file system. Okay? Don't worry about auto-loading it. Don't worry about recognizers. Don't worry about all that fiddling around. Manually load the sucker. Wire in the name of the device you're actually going to talk to. Return status not implemented on all non-working entry points. If you absolutely positively feel that you must have a mount and a dismount, or just a mount probably to start with, go ahead and write one. It's not a lot of code. It's not terribly complex. We haven't written a mount. The philosophy behind not having a mount in Windows NT is kind of an interesting one. Basically, the idea behind it was to make it simple. In some way, it probably made it more complex for people who are actually trying to implement a file system. But the philosophy was for a user to make it simple. The user doesn't have to worry about mounting floppies, doesn't have to worry about mounting particular devices. It's all just magically done for them behind their back. That was the idea behind all that. Daryl didn't really talk about that much yesterday, but that was our concept. One of those things is boomerang back and bit us big time. That's why for Cairo probably we'll have a mount and a dismount. And you guys will be the first to know about that stuff. But it's not rocket science to go ahead and write your own mount. Use a private iOctal or FS control to talk to your file system. Sideband communications are perfectly reasonable, and in fact, many drivers, if not most drivers, can do them. If you want to define your own private iOctal that only you understand, do it. There's no problem with doing it. Make it happen. Okay? If you feel a format is necessary, go ahead and write your own format. Our file systems have an integrated format and disk maintenance utilities. We actually, at the beginning of this conference, when we started planning for this conference, we're actually going to expose those interfaces, and then we started looking at those interfaces, and we decided we really wouldn't do you that favor, because it wouldn't be a favor. That interface for integrating check disk and format and those things is actually extraordinarily ugly and not extensible. So there's some revision going on to it to make it possible to integrate your disk maintenance utilities at some time in the future. But for now, don't worry about it. Just write your own disk maintenance utilities. Again, if you feel it's necessary to have, if you can't get it through the standard iOctals that we provide, go ahead and write your own, crank them out, you know. It's, again, it's just code. Yeah, the system will fall over if you've got it wrong, but presumably you're not going to ship it with it wrong. You're only going to use it on your own desk. Okay. I would suggest that you probably want to, this is not an exhaustive list, but I would suggest that you probably want to implement the file system in roughly, the entry points, in roughly this order. Now, what I don't have on here as a bullet is all of the stuff you need to do to maintain your on-disk structure within your file system. Presumably, you'll have to implement that, or at least get some version of the implementation of it done prior to actually implementing any of these entry points. And you can, you know, that again, you can do that and make sure you can go in there and poke around and look at things, that sort of thing, through the debugger and through test code that you write to look at your file system. However, when you ultimately do start implementing, go ahead and implement open first, because that's actually fairly interesting. And then implement cleanup and close. So that'll give you the ability to open and close the file, bang away on it. Implement read, now you can tell whether you've got something in it. Implement get info, and about this point you can start using WinFile to look at your file system. Because WinFile will use get info, etc., etc. Remember, return status not implemented. WinFile file manager will simply ignore those things that return status not implemented. Implement locks, because typically those are fairly interesting. Directory notify. Then go to set info. Now you're actually talking to your disk, so you're now going to start corrupting your disk. Up to now you haven't been corrupting your disk, you'll notice. So you've now got a good feeling. You've spent some time implementing. You're more comfortable with NT as an internal sort of thing. You're more comfortable being a kernel mode implementer in NT. So now you can implement set info. Set info is actually fairly benign. It doesn't do a lot of stuff. Finally, implement write. So you can go ahead and crank on things. Another thing we haven't talked about here, and we're not going to talk about for quite a while, is bootable file systems. You all actually have a leg up because you're not writing a file system Windows NT is going to boot off of. And we made a conscious decision not to expose that information here because A, it's fairly complex, and B, we're modifying it as we go because we found out half the time we haven't done it right and we need to rev it. So sometime in the future, okay, first step. If you absolutely feel like you need to boot from your file system, if it is something that absolutely positively must happen, come and talk to me and we can see what we can do to make that happen. I don't believe that's necessary in the near term for anyone here. However, I'm willing to be disabused of that notion. Okay. Daryl said this for testing. Self-host yourself as soon as you can. After you get write done, you ought to be able to keep all of your code on your file system. Within Microsoft, we call that eating your own dog food. And sometimes the taste of your dog food isn't quite as good as you might like it to be. Obviously, you want to keep a backup on something you trust. But if you have your developers self-hosted on the file system you're implementing, it's amazing how fast bugs get fixed. People absolutely want that stuff to work right, and nothing pisses off a developer faster than losing some code they just spent some time writing. Okay. Second, stress the systems heavily. Invest a little bit in some machines that you can stick on the network and run the server on top of your file system, or invest in some machines that you can stick somewhere and let them just crank away on your file system. Write some simple utilities that do reads and writes. I'll try to get some of the stress testing stuff that we use inside Microsoft out to all of you as quickly as I can get permission to do that. But this is what we use for doing our file systems. I would point you to Xcopy. Multiple X copies into and out of the same directory actually do some very interesting things to file systems, like tie them in knots. That sort of thing. Guerrilla testing is what we refer to it as. As you put in the new special function, the new functionality, especially functionality that's specific to your file system, bang away on testing it. Write a kernel mode thread that you fire off within the initialization routine in your device driver, and in that thread, bang on that API internally. Okay? All of these things are doable. I mean, they don't really sound like something that people usually think about doing, but it's just an operating system. I mean, there's no magic code here. Get in there, right? Start yourself a kernel mode thread and bang away on your APIs. That's one good way to test it. If you have special test code, write it as you go along. Now, to a certain extent, I'm teaching a whole bunch of software developers how to go about developing software, which is a stupid thing for me to stand up here and do. But on the other hand, what I wanted to do was give people the feeling that, in fact, this is an achievable task and it's something that you can approach now. I was afraid that, as a consequence of walking away from David's talk, people would be going, oh man, I've got 6 months worth of stuff before I can even start to make my file system come up. That's not true. I would think that most of you here, especially those of you here who have existing file systems, ought to be able to go home and have a very rudimentary version of your file system up within a month. Okay. It'll be crude. It wouldn't be something you'd ship to anybody. It'll be slow, but you ought to be able to be up and cranking away on it internally within a month or so. That's my opinion. Okay. Finally, as I said twice, the stuff that David Goebel talked about is folklore. You won't find it written down anywhere in the near future. It's in the head of 4 or 5 people who, every time they go across the bridge, I cringe because I'm just waiting for a bus to run over one of them. But part of the point of this conference and the videotape of this conference was to get that information down so that you could use it in the future. I fully expect that all of you will get to, curl up around the fire with your remote control in hand and watch David talk again and again and again. Yeah, well, okay, so now you have an excuse to upgrade your VCRs. Yeah, send transcripts. No, I don't think so. Anybody wants to do it and send it out to the mailing list, that's fine with me. The interactions go away. Interactions with the memory manager, interactions with the cache manager go away if you don't choose to use them. So if you're not supporting the fast I/O path, make sure you set the bit in the FSRTL header, the FCB header that says I don't support fast I/O. The I/O system won't use them. You'll never see a fast I/O call. You'll never have to use the cache manager. And get the stuff working. Make sure you understand how this stuff all works, and then integrate the cache manager. Nod your head, Brady. Okay. Start simple and work up. Everybody feel better now? You didn't feel bad to begin with, okay. All right. So I know some of you have to leave early, so I'm going to do a very, very brief recap of the information that I promised you for the end of the conference. My email name, dbeaver@microsoft.com. I put it at the header because I expect most of you will want to write it down. Don't use the telephone to call me. I know a lot of you really like the telephone. Please use email. It gives me the ability to manage my load better. I would encourage you, not for support, but for if you have problems, if you think you need information that you can't find anywhere else, etc., to drop me a line. I won't promise you that I'll turn it around within a day, but I will promise you that I'll turn it around. Okay. Use the other support mechanisms first. We do have product support people who are coming up to speed on this stuff, who want to help. I mean, it's their job to help. They're very helpful people. Okay. FSDev@microsoft.com if you have feedback on the IFS kit. Oh, what the hell. Whining about lack of content is not what I would consider to be feedback on FSDev@microsoft.com. Constructive criticism about what more content could be in it would be the kind of feedback I'd like. Whines will probably be summarily deleted. NTFSD@cmkrnl.com. Jamie Hanrahan at Kernel Mode Systems has put this internet mailing list together. For those of you who haven't used internet mailing lists before, if you want to subscribe to this mailing list, wait until tomorrow to do this, but if you want to subscribe to the mailing list, NTFSD-request, at cmkrnl.com. I lied. Okay, well, you saw me typing this in, I think. NTFSD request at cmkrnl.com. It's a standard list server, so subscribe, space, followed by your email name without the brackets, followed by your full name. And you can always just send an email message with help as the body of the email message. This is the body, this is text in the body of the email message. How many people out here haven't ever used internet mailing lists before? Okay, half a dozen of you. Okay, maybe a dozen. Okay. Finally, as I said, the technical support people from Microsoft, they're there, they want to help. They're standing back there. There they are. They're running. These are people who have lots of experience with Windows NT internals. They support device drivers now, so they understand kernel mode development very well. This is paid support, of course, because that's the way the operating system support works. the device driver kit stuff, the support works, but it is there, it is available. Finally, I'll segue a little bit into put my marketing hat on for just a second. If you're not a subscriber to MSDN Level 2, Microsoft Developer Network Level 2, please get a subscription to it as quickly as you can. It's $495 a year. For that, you get beta versions of operating systems as we make them generally available. You get at least the US release of all of the operating systems we make, which include Windows NT and regular Windows. You get the device driver kits, you get the software development kits for all of the products, all of the operating systems, and things like Mappy and Tappy and Zappy and Wappy and Lappy and all the rest of those silly APIs that we have. We're starting to run out of letters in the alphabet. So it's a great value. That's all I'll say. Okay. Now I'll go into what I was originally going to talk about. Questions, first of all? Yeah. Yeah, NTFSD -request@cmkrnl.com. That was wrong. This one is wrong, yeah. It's at Microsoft.com. It's automatic for me when I type Microsoft.com. Sorry. I wanted to get the information out, even if it was wrong. It's been one of those mornings. All right. As I said earlier, TDI stands for Transport Driver Interface. A little bit of history is probably in order here. You're probably saying to yourself, well, why is this marketing guy talking about this stuff? I mean, what's going on here? Before I was a marketing guy, I worked in the Windows NT development team. And my task was writing transports. I wrote NetBUI, which was the first transport we had running on Windows NT. And I wrote the first version of the transport driver interface spec. When we designed Windows NT, we knew we were going to be putting clients and servers and other sorts of things in the kernel. So we wanted a very fast path for I/O into and out of redirectors and servers, as well as a common interface to transports within the kernel. And TDI is that interface. I'm going to talk today very, very briefly about basic TDI, which is documented in the device driver kit. I'm going to spend considerably more time on advanced use of TDI, specifically some of the fiddles and gotchas and those sorts of things that people run into when using TDI. I'm going to talk a little bit about how TDI is used by servers and clients. And when I say clients, I mean a requester or a redirector or whoever, just somebody sitting on top of TDI to use it. I think probably that mostly testing performance discussion is probably a lie. It'll probably be about half and half. Oh, and finally, before we go much further, I'm a really interactive sort of guy, so if you have questions as we go along, please pop up your hand and I'll take questions as I go, as well as at the end. All right. TDI was really modeled to a certain extent along Berkeley socket lines, which sort of reflects TLI a little bit. I'm going to sling a lot of acronyms here because I'm a networking guy and I sling acronyms a lot. If you want to stop me and ask what they are, TLI is Transport Layer Interface. It's a Unix interface into transports. The primitives in TDI are connect, accept, listen, associate address, send, receive, datagrams as well, and disconnect. If you have experience at all with networking, that would be, you'd expect that. Okay. TDI is all built around the concept of a communications endpoint. A communications endpoint in TDI is implemented in Windows NT as a file handle. So if I'm a client to TDI, I will open a file handle to the transport, and then I will associate an address with that file handle. And now I have a communications endpoint. I can then listen on that endpoint. I can accept connects on that endpoint, and there are several different ways to accept connections that come in on that endpoint, and I'll talk about those in a minute. And I can send and receive. And as a bonus, in Windows NT, we decided it was absolutely vital that send and receive be capable of doing both stream and message-based transport support, as well as having the capability to read and write from the transport. So not only can you do a send and receive, you can also do a read and write. I think it's been a long time since I played around with any Unix, but I believe that's similar to what you can do in Unix. The question is, the associated address. The question is, does associated address have a port number associated with it, etc.? Associated address, I'll talk a little bit more about address management and what an address actually looks like, but the address that you supply in an associated address call is actually specific to the transport. And it depends on what the transport supports. Again, TDI is designed to support lots of different transports, so there are some places in transport support where you sort of have to punt, and associated address is the punt. So. The advanced features of TDI that we put into Windows NT are event handlers. One of the things that we didn't want to do with Windows NT was make the transports virtually synchronous. And by virtually synchronous, I mean we didn't want to have transports that wouldn't give you data unless you asked them for data. We wanted transports to have the ability to let you know they had data incoming. There are several different ways to do that. The way we chose to do this in TDI is with event handlers, which are callbacks into the client that the transport can use to notify the client that something has happened in the transport. Typically, that data has been received. There are other event handlers within TDI, and I'll talk about them. The differentiation, by the way, between advanced TDI and basic TDI is one that I make, not one that the documentation makes anywhere. Okay. We'll talk a little bit, this is actually an overview slide for the rest of the talk. We'll talk a little bit about managing connections. We'll talk about send receive and some fiddles around send receive. And finally about managing bindings between your client, your user of TDI, and the underlying transports and network cards. When we put TDI together, we envisioned that virtually all receives in the client and the server would come through event handlers. Event handlers are basically a callback into your client that allow the transport to say, gee, I have this data for you, here it is, indicate to you the first n bytes of the data, which I believe is 128 right now, and say, here's this data, what do you want to do with it? Joe Lynn will talk more about that specific piece of TDI in his talk later on. But it's important for you to understand that TDI is really event-driven. You set up the handle, you register the event handlers for a particular file handle, and after that you never bother saying, gee, I want to do a receive. The receives are just indicated to you. Now this whole thing gets a lot more complex. This is what Joe Lynn's going to talk about. And I'll talk about things other than that in this talk. But in general, what happens to you is you just get indicated, you get called saying, I have data for you, what do you want to do with it? Repeat after me, event-driven, 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 yeah, okay. The paradigm within Windows NT everywhere is that the most efficient way to deal with anything is to be event-driven. TDI was written to this philosophy, event-driven. The most efficient way to use TDI, the part of TDI that people in transports have spent the most time and effort on is in fact the event-driven path. In NetBUI, for example, there was tremendous amount of time and effort put on optimizing the path between the network card and the call into the client. And right now that's down, I don't know, do you know how many instructions that is, Mike? But it's a fairly small amount. It's in the less than hundreds of instructions, okay? Which for an operating system like NT really isn't that bad. If you make use of event handlers, good things will happen. You'll be fast. things will work well. If you don't make use of event handlers, you'll be sending ERPs to the transport to do receives, and that tends to be a fairly slow process. As Daryl mentioned yesterday, the overhead in building an ERP and shipping it to whatever driver is fairly significant. Okay. There is a single handler on a file handle for a given event, so you can't have multiple different ways of handling different events. However, that's differentiated across datagrams, so if you open a handle receive datagrams on, you can have a different receive handler for a datagram than you can for you have for a regular stream-oriented receive. Indications are given to you at DPC level. And let me repeat that. The call level for an indication is DPC. That has some significant implications. Primary among them is that you can't, in your call handler, you cannot allocate page pool, for example. Okay. There are lots of other things. Basically what it means is that if you're going to write a client, you're going to go through the DDK documentation and you're going to look at everything that can't be called at DPC level and you're going to say, oh, I can't use that. Okay. It's not guaranteed that every transport will call you at DPC level when it gives you an indication. However, you can't guarantee that it won't. Again, optimized, optimized, optimized. Okay. Now, remember that Windows NT is a multi-processor system. You can have multiple indications active at the same time within Windows NT on different handles. You'll only have one indication active on any handle at any one time, any file handle. However, you can have multiple indications active at any one time on different processors in the system. So you have to, if you write a single receive handler for multiple handles, you have to be smart about the fact that, in fact, those things may be executing simultaneously. The same code may be executing simultaneously in different parts of the system. So you'll need to spend a fair amount of time looking at synchronization issues, spin locking of your data structures, that sort of thing, to make sure that you don't do something that's going to cause you to fall over and twitch twice. I hear a yes.
Yeah, I mean, you're all, as long as you're looking one file handle, only has one block of data that you can use. Therefore, if you're, I mean, it doesn't matter how many processors that would be involved in a processing of density or how many processors you have. I mean, as long as you're
The question is, Jamie, what the heck are you talking about? It's a little more complex than that. The question is really, if I only have one file handle, how can I have multiple indications going on it? And you can't. The next question is, aren't the indications unique? My point was, yes, in fact, the indications on a particular file handle are unique. So you'll only have one indication outstanding on a particular file handle at any one time. However, if you write your code such that you have a single receive handler across multiple file handles, that code may be executing at the same time on multiple processors in the system. Okay, that is implication for spin locking structures. You need to spin lock a structure to right, your data structures within your client. So you need to think about this right up front in your client design. When you start thinking about designing a client, that's the reason I mention it now. People don't typically do that. They just say, oh, okay, well, we're going to get it. It's not serialized. The indications on a particular handle are serialized. However, the indications across multiple handles are not serialized. And that actually has some significant implications because that means that streams of data coming from different places may not be synchronized in precisely the form when they arrive at your client, may not be synchronized in precisely the form they were on the transport media, Ethernet, whatever. So a packet, your indication routine may actually receive a packet. How do I say this without causing people to spin up? Right. From one guy before the other. That's exactly the right way to say it. So, in other words, yeah, you're not guaranteed that the order you see data from multiple clients in your client, data from multiple remotes in your client is the same order that it was in on the Ethernet. Within a handle, within a single stream to a remote client, the data will be serialized. However, it will not be across multiple clients. Everybody thinking about that hard? Okay. TDI makes use of a lump of byte structure called a transport address. And that transport address, since we wanted to support multiple transports with TDI, that transport address is specific. When you do an associate address, you supply a transport address structure to the associate. That transport address structure is specific to the transport that you're talking to. However, that transport address structure is also designed such that you can put multiple addresses in it. So if, for example, you have a transport that could support either a NetBIOS address or a TCP address, an IP address, for example, you could put both of those addresses in the transport structure. The transport is only responsible for applying the first address that it understands in that transport address structure to the transport endpoint. Okay. Most people don't bother to do this, by the way. It's just a nice little feature. There is an event handler for an incoming connect request. It's actually a fairly interesting little fiddle because you can actually, when you get a connection event request, you can actually apply the address that you want it to connect to a handle and supply that back to the transport, and the transport is supposed to deal with making the connection occur on that particular event handle. So you get the connection request in, and then you can associate it with a different handle. This is very similar to kind of a forking sort of, or a socket cloning sort of functionality that you have in Unix. I don't believe anybody, I don't know whether anybody actually uses that very much because it actually turns out to be quite convoluted and gnarly to implement, but I know our transports do support it. I know at least NetBEUI supports it. So, you can actually have a pool of open file handles laying around if you want to, and then associate addresses with them as you go. This is probably a reasonable place to talk about the kind of things you can hand to TDI and expect timely completion on. Listen is about the only thing you can't expect a timely completion on. If you hand an ERP to TDI with a listen in it, it may never complete. And it's incumbent upon the transport to be able, when you close that handle, to be able to tear down that listen. And that's the way that listen gets torn down. And the ERP will get completed with status, status canceled, I believe. Okay. Hang up and receive interactions. If you have a receive outstanding and you hang up that connection, you do a disconnect, you will receive you will receive no more data on that connection. This is documented, but it's documented kind of unclearly in the DDK. So if I do a hang up on a connection, I won't receive any more data on that connection. However, I can still, if I do a hang up that is, there are two forms of hang ups. There are abrupt and I don't remember the term now, geez. There are abrupt, graceful, right. There are abrupt and graceful disconnects, and abrupt disconnects will hang you up right now, just terminate the connection. Graceful disconnects will allow you to finish sending what data you have left to send. Orderly disconnect, right? Okay. Now we start getting into some interesting stuff. When you do a send at TDI, sounds like it would be a pretty easy thing to do. You just do a send and go. Well, most of the transports out there, actually, when you do a send, you do an IO call driver and pass out an ERP that has the data that you have that you want to send. The transport will say, wow, okay, this is my ERP, it's got the data in it, the data's already mapped and locked down, I know that's the case, so I'll just make a copy of this MDL that describes this data, and I'll return success to the send. Okay? Because there's a send completion routine that gets called later. Again, this is documented in the DDK. What isn't documented in the DDK is the fact that most of the transports suck that MDL off and immediately call the send completion routine. Most people would say, wow, okay, I'm going to do a send, and as soon as I get the send completion routine, I'm going to do another send. This is a recursive plunge. You'll go straight to hell very quickly, run out of stack, remember you're in kernel mode, and you'll run out of stack very quickly. So you have to be a little careful about managing your sends. We've seen this in our redirectors. I believe others who are building redirectors have seen it as well. It's actually not too difficult to manage this. There is a is okay to send TDI primitive. You can actually ask the transport if it's okay to go ahead and send more data. So you can break out of this send, get a receive indication, get a send completion indication, send this death spiral. But you do have to be a little careful of your stack usage. And to be a little careful about the way you use this stuff. Okay. Did I hear a question?
What's the send completion really telling you? You need to come back and say that send is okay. What does that tell you in the case of an opportunity when it's banned?
The send complete, the question is, what does send completion actually tell you? And what send completion actually tells you is the transport has the data. The transport will get it to the remote. Okay. When a transport tells you it's got the data, it's not the same thing as saying that the remote has the data. This is the central question of transports and networking in general is, how do I know the client really has the data? Well, the only way you know is when the client actually tells you it has the data. And of course, then there's the question is, gee, did the client just not tell me it had the data, or did the data never really get there? You know, it's that classic background thing. So send completion indicates that the client has, that the transport has the data, and will make the best effort to get that data to the client, including retransmits whatever is necessary. So, sound any question over here?
Yeah, if you do a send, if you're doing it on behalf of a user mode client, do you copy the MDL or just copy the data from the MDL? Because I want to clear up the MDL and return to the user when it's complete.
The question is, if I'm doing a send from a user mode client and I pass it to, okay, maybe I didn't understand the question. Can you repeat the question again?
The user mode application asks me to send to the network, so I build an MDL.
Right.
And I send it down to the transport, and then my completion routine is called. So I want to tidy up everything and complete the user's IR.
Okay.
Have you copied the data from the MDL, or have you just kept a note of the MDL?
Yeah, the question is, what's the real mechanics of when I actually queue an ERP to a transport, and it has some user mode data. I'm a client, I've queued the ERP to the transport. What's the mechanics of freeing up the buffers and the MDLs that have been used by the, that have been handed to me? The answer to that is that when the request is put down to you by the client, okay, the user mode application says to the redirector, send this data. The redirector then turns around and says to the transport, send this data. Until the transport says it's finished with that data, you can't complete the user request, the original user request, unless you have copied data into internal buffers. Okay?
But you said the complete has already been called, but you might still use
Right. Well, send completion request is not the same thing as completing the ERP. Okay? So there's a little fiddle there. Was there another? There was another question. Yeah.
In summary, can we say that this level of the network is not responsible for a guaranteed delivery system, and that's responsibility of the layer up top or up higher?
The question is, yeah, if I can summarize the question is, who's responsible for guaranteed delivery? Yeah. Guaranteed delivery is ultimately the responsibility of the application doing the sending. In all cases, that's true. I mean, the transport can tell you that, in fact, most transports don't tell you that, in fact, the remote has received the data. They only tell you that they sent it on the network. Okay.
I said, yeah, typically you don't get told that you listen for and acknowledge. It's basically an exchange. I just don't know the intent behind TDI. It's not to do that, and I know to let line
Yeah. Basically, the question is, who's really responsible for making sure the data got there? And the answer is that the transport will send data, but the transport, unless the protocol has completed successfully, if all the transport can tell you is it got to the transport on the other side, not that a client on the other side got it. This is a question of gee, is the transport data made it? Has the application data made it? It's a question network people wrestle with all the time. And if the application absolutely positively has to know it made it, then the application has to do some kind of acknowledge protocol with the other end. Yeah.
Transport is by definition
the comment is the transport is responsible for making sure the data made it to the remote and delivering it to the layer above it. Is that your comment? Which is not true. The transport is responsible for making sure the data got to the other transport. That's all the transport's responsible for. If you want, yeah. Right. Okay. That's not necessarily the case. Yeah. Yeah. This is a good thing to take offline and talk about and argue about in great detail. Yeah, over a couple of dozen beers. Okay. Okay. With a receive event handler, when you actually get an indication in that you have a receive pending, Jolene again will talk a lot about this, but there are several ways you can get the data out of a receive event. You can either suck it out immediately, you can pass an ERP to the transport and say, gee, I want you to use this ERP for completing this request. You can also say, gee, I can't take this data now, too bad. If you do that, you'll never get indicated for that data again, so it's incumbent upon you as the client to remember that that data got indicated to you at some point in the past and to take that data out of there. That has, I don't recommend that you ever say, gee, I can't ever take this data. Because unless you do it exactly right, you won't ever take that data. Synchronization. Always release spin locks before you send. There are different levels of indications that you can use, that the transport can use within TDI. One of the most useful is the error indication. It's very possible to get called back into your transport at places you don't expect. You expect it, but you don't expect it at that particular time. And if you hold spin locks or your synchronization primitives across the send, what will happen is that if an error occurs, the transport catastrophically fails, the net card goes away, that sort of thing. You'll get called the error indication routine. If you then try to spin lock, well, we know where that path leads. You'll either hang the system or the system will fall over because you're trying to acquire the same spin lock twice in the same thread. So synchronization it's very, very incumbent upon the clients to be very, very careful about synchronization of your data structures. This is a recurring theme that you'll see all the way through today. It's very difficult to synchronize this stuff and do it properly. You have to be very careful, very thorough. Okay. Next to finally, if you are a client that supports multiple transports, as our LAN manager, I'll never break myself of calling it that. We're supposed to call it Windows networking now. As our LAN manager client does, it supports multiple transports. There is nothing in TDI that makes it easy or in fact in any way aids the process of supporting multiple transports. So if you're writing a client that uses multiple transports, potentially the same transport bound to multiple cards, the only way to know what the bindings are is to grovel through the registry and manage all this stuff yourself. It's very ugly. To quote our LAN manager redirector writer, if he could use a totally separate redirector for each binding, that would be the way he would prefer to do it. However, he doesn't get that luxury. So he's got a lot of code, and there's a lot of code in there to manage bindings. Think about that up front. It's actually a fairly troublesome problem. The binding here, in this case, it's effectively a separate transport if you support the same transport over two different net cards. You can logically treat them as different transports. I've already talked about error indications. If you enable error indications, which I encourage you to do because it's a good way to tell the transport's gone away underneath you, you also have to be careful about the code that you have written around those error indications, because terrible things can happen to you. You have to watch your spin locks, watch self-deadlocking if you're using events or resources rather. Yeah.
You seem to be using spin locks, whereas previous talkers have used resources. Is that just a personal preference?
The question is, I seem to be using spin locks where most of the previous talkers have talked about resources. It's a question of where you're going to take the stuff. You can't use a resource in a DPC. Okay? And remember that an error indication or an event indication occurs at DPC level. So typically, if you're going to do synchronization around this sort of thing, you have to do it with spin locks. You have no other primitives to use. So in most cases, you will see there is a sample transport in the device driver kit, and you'll see that virtually all of the data structures in it are locked using spin locks. And if I was to give you the landman redirector code, which I can't, you would see that in fact most of the data structures around it that have to do with sending data are in fact locked using spin locks as well. And the reason for that is exactly this event indication stuff. Okay. The final bullet on here, I didn't really know where to put this bullet. Very large reads and writes. Very large reads and writes are actually a problem for both servers and clients, not so much for servers, but certainly for clients. It's very possible for a user mode client to give you a 4 megabyte read or 4 megabyte write for the network. Well, it's also very possible that you won't have enough physical address space to lock down that entire 4 megabyte piece of data. And in fact, the problem actually is much worse than it, because it's very possible for a paged user mode client to give you a 1 megabyte write, for example. And it's very possible that you won't have enough physical memory to actually lock that down, which you must do before adding it to the transport. In these cases, it's actually allowable. It's a good thing Daryl's not here because he'd hit me. But it's actually allowable. In fact, our client will hijack the user's thread for the purpose of locking down pieces of the buffer and sending just those pieces that it can send. So if I can't map a whole megabyte, instead I build an MDL and I try to map the first half of it. And if that fails, I back off and try to map a quarter of a megabyte of it. And if that fails, I back off and try to, you get the way it's going. It's allowable to do that. The user said, gee, I want to send this 4 megabytes and I want to send it no matter what's going on. You need a thread to hijack to block while that transmit is going on. So you can use this user's thread in this case. Because what you'll be doing is locking it, sending it, locking the next piece, sending it, locking the next piece, sending it. The question is, what if the request was asynchronous? It's not. Yeah, this is one of those far-end cases that gee, it'd be really nice if the request in fact really did go asynchronously, and it's expected that you will use all possible speed to get that actually get that data the heck out of there. But in fact, if you absolutely positively have to send that data, you have two choices. You can either fail to write, which is very misleading, or you can say, okay, Mr. User, 4 megabytes, not a problem. It just takes a while. You know, we gotta blow it out. So. The question is, can you hijack it by sending APCs and only use it for that period? We don't recommend doing that. Actually building a kernel mode APC and getting back into the context of the calling thread, which is what you're suggesting doing, is an enormously expensive operation. There's all sorts of optimizations in the I/O system to allow that to happen on I/O completion. And there's actually two APCs that occur in that thread. You know, there's an APC that takes you back into the kernel mode context, and then there's an APC that takes you back into user mode context. So it tends to be fairly expensive. So we don't recommend that you do that.
So this has implications in the design of user mode processes which are providing services to multiple clients.
The question is, this has implications in the design of user mode services that are providing services to multiple clients. Yes, it does. And we'll talk about that in a bit on the server talk. Okay. Basically, what I want to do is give you kind of a grab bag of view of what TDI is capable of. There's all sorts of documentation around this stuff, but there's not much in the way of overview in the device driver kit. So I wanted to give you kind of a feeling for what kind of things you can do with TDI. To give you some pointers to, gee, don't do this, do that, don't do this, do that. Management issues in TDI primarily circle around the management of the handles that you use to communicate with TDI and the addresses, but bindings are a real pain in the butt. And questions?
Is there any support within the TDI interface for promiscuous type services?
The question is there any support in the TDI interface for promiscuous type services? What do you mean by that?
Take, for example, if you wanted to implement a format router, could you register yourself to respond to arbitrary ranges of addresses?
The response to that is, let's say I wanted to provide some form of router or router, as you pronounce it. Could I indicate to the to a TDI transport that I wanted to respond to all sorts of to every address effectively, to get receive indications on every address. I don't believe we have explicit support for that in TDI. However, the netcard interfaces do have that. However, then you have the filtering problem of, gee, now I'm getting everything off the network, which do I actually want to get? And I don't believe we have that capability. That Mike, you might actually be able to tell me. I don't believe we don't have the capability in TDI of actually saying, gee, I want to get every possible piece of data coming in on a particular transport type.
You can for, say, datagrams with UDP.
Right, yeah. Datagrams are, of course, an exception, but not for connection or anything.
And you can effectively pay a transport.
Yeah.
So you're talking
Yeah. So the point is that you want to implement a transport to do that sort of thing over the top of the image layer.
You mentioned that one cannot take resources in a DPC. Is it okay to release resources in a DPC? Because this is a type of...
Yeah, I understand the question. Mary, do you know the answer to that? I'm sorry. The question was, I mentioned that it's not possible to take a resource in a DPC. Is it possible to release a resource in a DPC? That was the answer. Yeah.
I wondered if you could expand a little bit on the binding multiple addresses. Is that true of both? That you're going to be an active client and passive? And what does that mean if bound yourself or associated yourself with multiple addresses on the passive side.
Okay, none of the transports support, none of the transports that are available today support binding to more than one address at the same time. It's possible to pass multiple addresses. I'm sorry. I assume the question is that, let's say I pass multiple addresses in my associate address structure.
Yeah, you even mentioned that you said you could pass a TCP or net buoy address
Exactly.
simultaneously.
The
Which would mean
transport-
two different transports, essentially.
The transport's responsibility is to respond to the, to bind to the first of those addresses in the transport address structure that it understands. No more. It's not required to respond to multiple of those addresses, or in fact to understand multiple of those addresses. The first address it comes to in that structure that it understands, it binds to that endpoint, and that's where it stops. There's no multiple bindings of addresses to endpoints going on.
So I'm not getting multiple transports activated by doing that.
No.
Or I'm not declaring myself to be a client or server of multiple addresses simultaneously and letting TDI do the demultiplexing.
No.
Okay. Well, when would you use it then?
Well, I don't think any of our redirectors or anybody uses it, but it is there. It's a feature that's there, so if you want to write a transport that uses it, have a nice day. So a question over here. The question is, if I have a redirector that wants to do multiple sends, one after the other, is it okay for the redirector? Does the redirector actually have to request a response from the transport? Is it okay to send? This stuff is actually a little more complicated than that. I just wanted to make you, what I would do is refer you to the DDK documentation and maybe bring this question up with Joe, who probably can answer it better than I can. But I wanted to make you aware of this potential problem. And I'm not really the right guy to answer the question. So bring it up with Joe later on. He looks at me, he hates me. And he can probably answer it better than I can.
I assume, and like actually, you have to wait for the, you have to send it out multiple blocks. I mean, there's
Right. The question is, when I talked about hijacking user credit earlier, I was talking about the simple path of GA, which is really huge write-in, or you know, writes typically where it happens. I can just really huge write-in. I'm going to block the user's thread while I go ahead and partition that write-up and then send it out as necessary. So you're mentioning that it's in fact the simple path that is. Oh, right. The question is it just a simple path from the answer? Yeah. That's basically what you're doing. The question is, there's nothing specific to NT about this. This problem isn't a problem specific to NT. It's just, this is the way it's solved in NT. Yeah, right here.
What is the bottom line to solve that? If you thought large messages were increasing in importance, then you might want some model where you say to how you can send the problem, or you're going to set the bus. I've got a set not easy things did a lot of he said that's how you try to
Okay.
you can't talk about users very well.
Yeah. The question is, are there other ways to solve this problem effectively? If I thought very large reading, very large writes were increasing in importance and I needed to service them, there's always one way to solve it, and find more memory. If you have more physical memory available, it's easier to lock in large buffers.
I think the interpretation of the problem is not locking down the entire user buffer, right? It's like they give you a loop that's driven by set not busy things, where you lock down a little bit more, set it a little bit more depending on the cost.
Yeah, the comment is that you need to lock down pieces of the buffer and have it driven by set not busy event. Yeah, that's right.
I don't think you can lock down the user correctly. I think you can bounce off the basic.
the question is, can you lock down the user's thread while you're doing this? Is it the right thing to do to lock down the user's thread while you're doing this? Lock the user's thread while you're doing this. And yes, it is the right thing to do to lock down the user's thread. To lock down the user's thread while you're doing this, rather than pass it off to somewhere else. Because remember, when you start locking down pieces of buffers and mapping them into user mode, that has to be done in the context of the calling thread. The user mode thread is it, so you have to get back in that context. That's where the problem exists. Right. The comment here is that there's other operating systems solve this by mapping in the kernel address space. Well, that's what you're trying to do. But you want not physical memory to do it. Okay. The comment is that other operating systems solve it differently. Yeah. Okay.
Several of these transforms are and so in many cases you should be able to just send them a walk down when you get your own page back again and walk along sitting on top of there you determine that you can set them a walk.
And the comment is that transports are going to solve this themselves in many cases.
If you're talking 10.5% of these out there, you're talking 256 byte buffer. I mean, transport is going to break it down on that one.
Right. And that's not always true. And this is actually a fairly good discussion, but it's not really germane to this particular piece of things. We should probably take it offline and discuss it later on.
At the receive indication at DPC level, when it comes to enhanced worker thread or some thread,
the question is, if I get a DPC indication, I'm in a receive indication, and I want to post it to a worker thread, can I do that? The answer is yes, you can do that. But what you're posting is the completion of the receive in the ERP that you've queued to receive the data. If you suck the data out immediately, remember that, again, Joel is going to talk about this in some detail later on, so I don't want to get too wound up in this, but yes, you can do that. It's just that exactly what you're posting to the worker thread is where that's where the magic lies. Okay. All right. Let's go on to the server talk.